We are member from Group 3, Subgroup 4. I am Tan Sing Ro, 106530.
My name is Rosini, 106745.
My name is Aisha Nadira, 97234.
My name is Alicia Gabriel Jo, metric number 103230.
So today we will present Practical 3, which is physical property of different lipids and fatty acids.
The objectives for this practical are to investigate and characterize the physical properties of lipids and fatty acids, and to evaluate and compare the solubility profiles of lipid-containing products in both polar, water, and non-polar, toluene, solvent systems.
Materials used in Practical 3 are distilled water, toluene, olive oil, ghee oil, and shortening oil, while the apparatus used in this practical are a dropper, microcentrifuge tubes and rack, micropipette and tip, and laboratory mixer. Two sets of 3 separate microcentrifuge tubes were prepared and labeled. A small amount of olive oil, shortening oil, and ghee oil were added to 2 test tips respectively. Ghee oil is yellow semi-solid, has buttery aroma. Olive oil is yellow liquid, has greasy smell. Shortening oil is white cream and odorless. 1 ml of distilled water was added to each centrifuge tube in the first step. The tubes were tapped and shaken to mix. After distilled water was added and mixed, olive oil, shortening oil, and ghee oil all show insoluble in water. 0.5 ml of toluene was added to each sample in the second step. These tubes were also tapped and shaken. After toluene was added and mixed, ghee oil, shortening oil, and olive oil all show soluble in toluene.
In conclusion, this practical has successfully achieved its objective by investigating the physical properties and solubility behavior of different lipids and fatty acids. Based on the observation, olive oil, shortening, and ghee show different appearance and odor, but all share the same solubility characteristic, where they were insoluble in water but soluble in toluene. This finding confirmed that lipids are non-polar and hydrophobic compounds. This practical also demonstrates the principle of light dissolves light, where non-polar lipids dissolve in non-polar solvent, but not in polar solvents such as water. Overall, this practical provides a better understanding of the physical properties of lipids and the relationship between the molecular structure and the solubility behavior.
From this practical, I learned that the structure and saturation of lipids affect their physical properties. Unsaturated lipids like olive oil remain liquid at room temperature, while saturated lipids such as ghee are more solid due to the stronger molecular interaction. Lipids did not dissolve in water because they are non-polar, but they dissolve in toluene since both are non-polar substances. This shows the hydrophobic and lipophilic nature of lipids. In addition, the experiment improved my skills in conducting solubility tests and making laboratory observations.
For the challenges that we faced during this practical session is that the identifying of the smell and also the measurement inaccuracy. So the describing of the exact odors of the lipid were quite difficult and highly subjective as the smell were perceived differently by each of the team members. And also for the measurement inaccuracy, the usage of manual dropper made it hard to get an accurate measurement as the actual volume and the size of each drop could vary between the different lipids. Next is for the improvement, which is the use of a micropipette. So instead of relying on a manual droppers, The use of micropipettes by setting a specific and precise volume for the liquid samples can eliminate the human errors and guarantee a uniform quantity.